Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. I hope you guys are all having a wonderful day. And yeah, let's go ahead and talk about life, liberty, the pursuit of open source software, and where we're going today. Emrys, thank you so much for coming in. And also, Faust Petrovic, thank you so much for the 3 months subscription. I'm going to go ahead and put 3 Simulecows in the chat. Honestly, I need to figure out something to do for people who are subscribed to this channel for a while. I haven't figured it out yet. So if you guys have any ideas of things that I could do to celebrate people who have subscribed to this channel for, I don't know, maybe like 3 months, 6 months, 12 months, 2 years, this type of stuff. I kind of want to find a way to celebrate that, you know? And I don't know the best way to do that. So if you guys have ideas, feel free to let me know. I mean, I guess we could do like special Discord flair or something. I don't know. I have to kind of think about it a bit. But anyway, I'm glad you guys are all here. And I hope you guys have all had a wonderful day. I know a lot of you guys are, just hanging out at home now because of the coronavirus stuff. So if you are struggling because, maybe you know someone who is affected by coronavirus, or, your job is somehow not doing as well because of coronavirus. Does that make sense? Like, I totally understand. And I'm hoping that just for the next few hours, we can hang out, chat, talk a bit about Easter algorithms, and have some fun together. Take our mind off of the whole grim reality that a lot of people have to deal with nowadays. That said, I don't know. It's just such a weird time, and I don't really want to talk about it too much today. I will say that Easter has now become a somewhat political topic as of yesterday, because that's the day that Trump wants to reopen America, and a lot of people think that's too soon. I have no idea about any of that. All I'm going to say is we're going to be calculating the date of Easter today. That's the goal, and we're going to try to find a way to make it intuitive as to how and why we calculate Easter in the way we do. Another thing I want to talk about is kind of the nuances of the algorithm itself. Right now, we're going to be using Gauss's Easter algorithm, which we covered in sufficient detail yesterday. But I'm trying to figure out the best way, again, to show that what we're doing makes sense, which is not clear at all. It's something that even Gauss was unable to do, because when people asked him how and why his algorithm worked the way it did, he basically said that it works because of math, right? Which isn't really a sufficient explanation in my opinion. So I think we need to go a bit further than that, and we'll see where we go. Again, guys, if you have any comments, questions, concerns, ideas, anything like that, please feel free to let me know as soon as feel free to let me know, and I'll try to address it as soon as I see it in chat. First things first, let's go ahead and open up Zernal PP, talk a bit about what we're doing here, why the Easter algorithm is so important and also so challenging in some ways, and then we're going to go from there. Again, feel free to talk about anything you want to talk about in chat, and we'll go ahead and get started. All right, let's go. Zernal PP. One thing, okay, look, I know Zernal++ is not Zernal, but I used to just use Zernal to open it up, right? But now Zernal isn't an actual command. I have Zernal and Zernal Thumbnailer, which I don't even know what that is, if I'm being honest. Yeah, no idea. So, I don't know. About software development, make it correct, make it clear, make it fast, in that order. Right, I actually think that there's some reason why you'd want to make it clear without making it correct. And that is to say, sometimes you need to write good documentation, and that, or like a lot of times when you're writing physics code or something like that, you know exactly what you want to do. You can make it clear what it is you want to do. And I think that a lot of people just go from, I guess a lot of people do it in the following order. They make it correct, and then they make it fast without ever making it clear. That is to say, they don't have proper documentation. And I argue that a lot of times your code comes out from coming up with the appropriate structure to make it clear. Sometimes that happens. I don't know. But I agree with that statement pretty much wholeheartedly. So, okay. So let's go ahead and go. Let's talk about Easter. Let's talk about where we're going today. I figure today might be a bit quieter than the past few days. In the past few days, we've had raids from big streamers. That's not necessarily going to happen today, and nor do I think it needs to happen. So it might be a bit cozier. It might be a few less people chatting. And I think that's fine. It's more time to hang out with you guys and enjoy the time together. So, Easter. Right. So most of you guys, if you've been here for the past few days, you know what we're talking about. We're talking about Gauss's Easter algorithm. Easter is a date that it's a holiday in the Christian calendar. Now, this particular holiday happens the the Sunday after the first full moon of spring, right? So that's sprig. Let me try that again. Of spring. So spring is defined as March 21st. Well, actually, first full moon after spring equinox is actually technically when this is. Actually, when does spring start? I don't even know. First full moon after spring equinox. I'm just going to type in EQ, and I'm just going to assume that everyone knows that I mean equinox, right? So the spring equinox is defined to be March 21st. I know technically the spring equinox is like a range between the 19th and 22nd, but the Pope in the church said it's always going to be on the 21st. So we're just going with the Pope on this one. It's going to be on the 21st, right? Okay, I'm going to change my color. I kind of want some pink today. So we have the Sunday after the first full moon and the spring equinox. So this means we have two things we have to take into account. One, we have to take into account the lunar calendar, because we have to figure out when the first full moon after the spring equinox is. And then we have to take into account the Gregorian calendar, which is a calendar we typically use, Monday through Friday, 365 days a year. So this is calendar 1 and this is calendar 2. Because we have two different calendars that we have to take into account, this isn't actually straightforward. And a lot of astronomy, and I guess astrology as well, is dedicated to the art of understanding calendars. It's actually a rather difficult thing to figure out. Now, historically, the date of Easter was one of the most challenging computations of its time, and was also one of the few things that people actually had to compute during the time. So this calculation was dubbed computus, which just means the computation in Latin. And the reason it was dubbed this was because it was the computation that people were doing. It was basically the biggest thing people needed calculators for from 300 AD to basically 1800. It fundamentally revolutionized the field, the boundary of human knowledge, and it's an incredibly important algorithm because it allowed us to understand a lot of things that we didn't understand before. And this calculation also pushed the development of multiple calendar systems. It's actually revolutionary in a lot of ways. The algorithm we're covering today was first developed in 1800 by Gauss. If you don't know who Gauss is, he is an amazing mathematician, one of the best of his time. He came up with, Gaussian distribution, Gaussian elimination. He came up with Gauss's law. He also came up with the Cooley-Tukey method, which notably doesn't have his name in it. That's because people forgot he came up with it because he came up with so much stuff. And then later, when Cooley-Tukey reinvented it, they only then realized, hey, actually, Gauss did this 200 years before. The guy's a genius. But actually, between the years 1800 and 1815, I want to say, he developed 7 or so different methods to develop this particular, to find this date. That is to say, Gauss, being one of the most intelligent mathematicians of his time, still struggled with this. So if I say or do something that is complicated, no, you're in good company. There are a lot of people, incredibly intelligent people, who struggled with this. So please let me know what you're thinking, and I'll do what I can to answer whatever you say, whatever questions you might have, as soon as I see them in the chat. Technically, a season starts at the traditional date of the corresponding equinox or solstice. See, I didn't know that. So that means the spring equinox would technically be the first day in spring. Is that true? Oh, this is, I was looking at Boston weather because for some reason I was feeling rather cold. It's been a while since I felt this cold. I don't know why I feel so cold. And I know I could turn up the air conditioning or the heater or whatever, but come on, why am I going to waste gas if I don't have to waste gas, Okay, so what I was going to say is, first day of spring. So if you guys are wondering where we are, we've already implemented the algorithm, and we are at the stage where we're trying to understand the bits and pieces of it. First day in spring is Thursday, March. Yeah, okay, it is the equinox. You guys, you're correct, Amaris. I just didn't know. It's new information for me. Gauss was actually dubbed the Prince of Mathematics at most 1 year after his death. This is actually huge. What? Is that true? That's amazing. No. Oh boy, I'm gonna make this a bit smaller so I can read it. I realize you guys might not be able to, but I'll try to keep you guys caught up. Prince of Math, the Prince of Mathematicians. No way. The fact that he came up in the Google search, though, I mean, clearly, boy, oh boy, that is wonderful. Let's see. The son of, I don't care. What are you doing? I don't want to join using either of these guys. Okay. Let's see. The son of peasant parents, both were illiterate, he developed a staggering number of important ideas that had many more named after him. Many have referred to him. Oh my gosh, I can't read today. Let me try reading this sentence again. He developed a staggering number of important ideas and had many more named after him. Many have referred to him as the princeps To be fair, that word wasn't English. Prince of mathematicians. As part of his doctoral dissertation, at the age of 21, Gauss was one of the first to prove the fundamental theorem of algebra. He went on to publish seminal works in many fields of mathematics, including number theory, algebra, statistics, analysis, differential geometry, geodesy, I don't know what that is, geophysics, electrostatics, astronomy, optics, etc. Number theory was Gauss's favorite, and he referred to number theory as the queen of mathematics. So if he's the king of mathematics, and number theory is the queen of mathematics, what is the domain at which they govern over is the question, and I'm not really sure. Okay, so let's go ahead and open up Computus over here. Computus there, and let's talk about where we're at. I'm going to open up some code. We'll talk about some stuff. I also, again, want to open up Sir Voice's table over here. Again, yesterday's main goal was understanding the algorithm. Today's main goal is to better understand or to better visualize this. So now we know what's happening from yesterday's stream. Today's going to be trying to figure out how to take that and run with it, how to make something more interesting with it. So we'll go from there. Yeah, also, I just realized I'm streaming an hour earlier than normal, and I didn't realize that until just now because I am an idiot. So, okay, that kind of makes sense a bit. In that, okay, what time is it? Is it 5 o'clock in Boston? It's 5 o'clock in Boston, isn't it? Oops, I got my time zones off, and I'm just now noticing that right now. So I might get a few emails during this time that I need to answer, and that is a bit unfortunate. So, right, we'll see how this goes, because I just got another email right now. And so, yeah. Okay, well, that makes a lot of sense, at least. Now I understand why, why people were still in the midst of working at this point. Okay, I'm just going to keep going. I'm not going to worry too much about it. I'm just going to go. Yeah, you might be alone in chat, but that's okay. You know, if anyone's here for the first time, hey, thanks for being here. Geodesy is probably the study of straight lines in curved space. Oh, cool. Sounds fun. I guess geo being like Earth or something like that. So Earth would be the curved space, and a straight line would be, I don't know, interesting. Okay. So let's go from there. I can't believe I started, oh man, what was I thinking? How did I get my time zones wrong? Okay. That just says that I've been inside all day and I actually don't know what's going on anymore. So let's open up this guy, and we'll open up this guy, and let's just scroll all the way down to the bottom of this page. Although this isn't particularly useful since yesterday we figured out exactly what the algorithm is doing. So another thing I want to talk a bit about is the Metonic Cycle. I can't believe I just got my time zones wrong. It's still just bugging me. How did I get to this point that I've lost track of the hour of the day that I'm on, you know? Which means probably what's going to happen is I will probably stream for 2 hours like normal, but it'll end at 7 o'clock p.m. instead of 8 o'clock p.m. And the reason for that is I just got an email from some people at work, and I need to get some stuff done for work before I go to bed tonight. So it is what it is. Normally I would have a ramping down period. I'd have a ramping down period after work where I finish everything up before stream, but it is what it is. Okay. Let's just keep going. I'm not gonna worry about it. Okay. Let's see. Okay. Good. Nothing crazy. Let's go. So let's go through the algorithm and let's talk about what each of the components are. I'm going to move that over there, move that over here. We're going to CD projects simuleos, and we're going to also CD over here, CD projects simuleos. And we're just going to go into CD computus as well. Computus and CD computus here. Okay, so the first thing I'm going to do is I'm going to open up the file. should just be Gauss Easter.jl. Now, yesterday, you can see we have all these comments here. Basically a whole bunch of comments. I'm just going to read through this file to make sure it kind of makes sense. Now, we still have an ongoing discussion of what we should call the variables, right? Because Gauss's Easter algorithm is, well, it's an algorithm from the 18th century, right? Like, it is what it is. It's more of a computation than it is an algorithm, right? It doesn't really make use of modern computing architecture as much as it just makes use of a calculator, right? Because of that, all these variables are kind of defined as weird characters, So you have A, B, C, K, P, Q, M, N, D, and E, and these don't make any intuitive sense, right? So because they don't make any intuitive sense, it's kind of, I don't know how to put this, it is kind of hard to read, right? And like I said at the start of stream, there were a lot of people who asked Gauss, hey, how did you come up with this? Why is this the way it is? And his answer to all of them was always, it is what it is because it's just higher level math. And so there's an ongoing discussion that I'm having internally, and some people had yesterday on stream, as to whether we should expand on these variable names. Like, say that A is an A, but instead the location of our date on the Metonic Cycle. This type of thing. This is the stuff that we're trying to figure out. So if you guys have questions or you have better ways in order to make this code clearer or more understandable, let me know. This code will eventually be worked into something that we can use for the algorithm archive. There's one last thing that I want to do before going a bit further here, and that is adding in the exceptions to certain days at the bottom here. So for example, we've already been able to calculate the date of Easter for most years, but there are exceptions where if D is equal to 29 and E is equal to 6, we replace the 26th of April with the 19th of April, which is just minus 7 from D, I think. And then we say if D is equal to 28 and E is equal to 6, and 11M plus 11 mod 30 is less than 19, where we replace the 25th of April with the 18th of April. So that means if we are on the 26th of April, we bring it back a week, and if we are on the 25th of April, we bring it back a week, right? So that's kind of the idea. So we're just going to have to subtract 7 from D or something if those cases happen. So let's go ahead and do that right now, and we will go from there. So what are we going to do? Down here we have if 22 plus D is greater than 31, then we're going to be in April. And what I want to do is I want to go ahead and add some if statements in here. I'm not exactly sure why we do what we do here. I'm not exactly sure why these if statements are what they are. So I'm going to go ahead and put them in, and then we'll worry about justifying them later. So modifying, let's just modify it already. So if, let's see, D is equal to 29 and E is equal to 6. And is this one? E is equal to 6. Then we have another else if here. And this is going to be if, D is equal to 28 and E is equal to 6. And, and E is equal to 6. And there's one more in this one, and that's going to be 11M plus 11 mod 30 is less than 19. Ooh, that one's a tough one. 11 times M plus 11. Then we're going to do modulo 30 is less than 19. And it should be something like this. Mod. Was that correct? If 11M is less than 19. Right. So for both of these cases, I guess we could have put that all into one big statement. We can say that, and then we can do, because we're going to do the same thing in both cases. So this means this would work. Okay, I think that's fine. And then I'm just going to put parentheses around this because I feel like it. And let's go down here and end. And we're just going to say D minus equals, is that 4 or 5? D minus equals, minus equals 7. Okay? So basically what we did is we subtracted 7 from D in those cases. So I'm going to try to find an exception year where we had to do that. And then we'll make sure that these years work as expected. There are historical exceptions. Sometimes you just have Easter the Sunday before the full moon. Oh, wait, okay, yeah, let me read up on that, see what these exceptions are. It's probably mentioned down here as to why they made the exception. That's kind of my question. Let's see. The expression d plus e can yield offsets in the range 0 to 35, pointing to possible Easter Sundays on March 22nd to April 26th. For reasons of historical compatibility, all offsets of 35 and some 34 are subtracted by 7, jumping one Sunday back to the day before the full moon, in effect using a negative e of -1. This means that 26th of April is never Easter Sunday, and 19th of April is overrepresented. These latter corrections are for historical reasons only and have nothing to do with mathematical algorithm. Okay, fair enough. So these, you're right, and actually the way that they said to do it, instead of subtracting 7 from D, we just set e equal to -1. Oh, -1. Okay, and we'll say historical corrections. For the 20, what is it? It's the 28th and 29th, so this is going to have to be April 25th and 26th. And 26th. Let me read this through one more time. So let's see. So it says that the expression DE, let's see, can yield offsets in the range of 0 to 35, pointing to possible Easter Sundays on March 22nd to April 26th. For reasons of historical compatibility, all offsets of 35 and some of 34 are subtracted by 7. Okay, so the 26th of April is never Easter Sunday, and the 19th of April is overrepresented. Wait, but that only accounts for... That's only this case. Yeah, why are we replacing the 25th with April 18th then? Because that seems that's a different case than what's represented there. It doesn't mention April 25th exactly. But I guess it's fine. It doesn't matter too much. We'll just keep going, see how it goes. Cool. So that would be those. And let me go ahead and check to see if we have any... So I guess I'm going to look for all the dates of Easter. And one of them has to happen on April 19th, right? So I guess we just look for any of them that happen on April 19th. Oh, actually, let's... How should I do this? So what I'm looking for is specifically a day or an event. I'm looking for a date of Easter that was supposed to be on April 25th or April 26th. And actually, now that I think about it, and just thinking about it right now, what does the 11m plus 11 less than 19 mean for this particular statement here? So I get that this one's for historical reasons, and I suppose this one's for historical reasons as well. But what is if d is equal to 28 and e is equal to 6, right? So we're one day off, and 11m plus 11 mod 30 is less than 19. What does that statement mean? 11m plus 11. So m in this case is going to be the correction to the starting point of the calculation each century, mod 30, because the lunar calendar is about 30. So what does that mean? 11m plus 11 less than 19. I feel like 19 might be the number of months in the Metonic calendar, maybe? Yeah, and this is what I was talking about. I just got a notification from work. 1 second. Okay, I'm just double checking here that right. Okay, 1 second. I have to respond to something from work. I apologize. Yep, sorry about that. That was my bad for starting stream an hour early. I don't know how. I have no idea how. I thought that 5 was 6. I mean, except I know my clock down here says 6 o'clock. that you guys can't see, but my clock is actually the wrong clock. My clock says it's 6 o'clock, 6:43 a.m. Japanese Standard Time. And what I do is I, in my head, do the conversion every time I look at it. So probably what I did is I looked at it and I didn't do the conversion because I'm an idiot. That's probably what happened. But it's okay. It's fine. It's not a big deal. Right, so my question is, what does this 11m plus 11 do? So what I'm going to do is I'm actually going to go to a different website that sometimes has information as well. We went through this website the other day. It's wonderful. He's got a whole bunch of different algorithms. One for Christmas. That's my favorite algorithm I've ever seen. It's just, this year Christmas will be on the 25th of December. Wonderful algorithm. This guy is just, he's a genius. I never would have thought to make an algorithm for this. I don't know. Okay, so finally there's one caveat. The length of a moon month is not exactly 30 days, but 29.53. This means that for large values of D, I don't think he even mentions it. Oh, if the result is April 26th, let me just read this whole sentence. Finally, there's one caveat left. The length of a moon month is not exactly 30 days, but 29.53. This means that for large values of D, we might find a PFM, which I don't know what the PFM stands for, that is 1 day late. And if that happens to be Sunday, then we will end up with an Easter date that is an entire week overdue. Therefore, the final correction, if f is equal to 57, or f equals 56, and e equals 6, and a is greater than 10, okay, then f equals f minus 7. So he's doing this is the same calculation, the same thing that we just did. This should be read as, if the result is April 26th, then subtract 1 week. If the result is April 25th, and the day after the Paschal full moon, that's what PFM stands for, is on a Monday, e is equal to 6, and the year is in the second half of the Metonic Cycle, then subtract 1 from the week. Okay, wait, let me think about that. Right, thanks, Don. Appreciate that. Please note the following. A ranges from 0 to 18, so the threshold of A greater than 10 means A over 18 greater than 10 over 18. Wait, let me reread this. Please note that the following. A ranges from 0 to 18, so the threshold of A greater than 10 means A over 18 is 10 over 15, 0.55, being practically equal to the fractional part of the length of the full of the month, of the moon month. Okay, let me think about this again. So, why if... let me just reread this because I think I didn't fully understand it. So it's saying, finally, there's one caveat left. The length of a moon month is not exactly 30 days, but 29.53. This means that for large values of D, and D in his case is going to be, I think, the same as D in our case. Right, I think so. We might find a Paschal full moon that is 1 day late, and if that happens to be on a Sunday, then it will end up with an Easter date that is an entire week overdue. Okay, therefore the one final correction, if f is equal to 57 or f equals 56 and e is equal to 6 and a is greater than 7, or greater than 10, then f is equal to f minus 7 must be applied. Okay, so that's if the result is April 26th. Basically, if the result is April 26th, our assumption is that we are 1 day off for the Paschal full moon. We might find that the Paschal full moon is 1 day late, and if that happens to be on a Sunday, we will end up with an Easter date this entire week. Okay, right. So basically what we're trying to do is we're trying to check to see if our Paschal full moon is 1 day off, and if it's 1 day off on a Sunday, which would then mean that we're 1 week ahead, which is why we subtract a week instead of add a week. Okay, fair enough. Now, if the result is April 25th, and the day after the Paschal full moon is a Monday, right? So that would mean that, what does that mean? That means that we're on a Sunday again. That seems fine. And the year is the second half of the Metonic Cycle. Then we subtract 1 week. So why does it being on the second half of the Metonic Cycle matter here? That's my question. Hey, Fulster, how are you? I hope you're having a wonderful day. How have you been, by the way? I feel like it's been ages since I've seen you. Oh man, I'm just getting all these notifications from work. It's okay. It's okay. I just need to read through them. Let's see. Okay, that was just a notification saying that we have a new meeting. I don't know about you guys, but ever since ever since I started working remotely for MIT, like for the past month or whatever, I've been just a huge number of meetings, just an insane number of meetings. Like it's just meeting. I have a meeting every day at 10, a meeting every day at 1, just so many meetings. And yeah, we're getting work done, but the main thing I've been doing is just meeting with people and helping them debug things. I haven't been writing any code. Like people have just been coming to me, or I've been helping them out. So like we just meet, and all of a sudden, they're just like, I can't get this to work. And I'm like, okay, let's try to get it working. And that's my whole thing. It's just meet, debug. That's my whole life right now. But that's fine. That's how it is sometimes. Good. I'm glad you're doing well, Folster. Reduce streaming early. Right. That was an accident. I, for some reason thought 6 o'clock was 5 o'clock, or rather I thought that I was an hour off for some reason. I don't know how, but I was an hour ahead in my mind. So when I started stream, I thought it was actually 6 o'clock, PM, but no, it was actually 5 o'clock. So I screwed up a bit there. Sorry about that. If anyone's coming in late and you guys want me to talk a bit about what we're doing again, feel free to let me know. Consequently, I might also be streaming early, or leaving stream early. But that's just because now I missed my hour. So usually what happens is I finish work at 5, and then I have an hour to kind of, not just to finish all of the things, right? Like just to finish it all up, and try to get ready for stream by just wrapping up all the loose ends. But I missed that hour, so now I have to, I gotta go back and do that hour after stream now. So we'll see how it goes. Debugging is harder than coding. I think that's in general. Yeah, I think that's in general probably true, right? It's just, the problem is we're working on this insanely large code base for what we're doing. And because of that, it gets rather complicated when we talk about just certain things. Like things get complicated. Also, Fulster, thank you so much for the sub. 20 months. Let's go ahead and add some Samuel cows in the chat. 20 of them. That's crazy, man. Like I was saying before, I really need to. 2, 3, 4, 5. Oh no. Let me try that again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that should be it. Maybe I did 21, but that's it. That's how many I'm putting down. And that's 20. That has to be 20. Like look, on my screen it looks like 20. But yeah, I really appreciate all the support. I need to figure out something to do for people who have subscribed for a very long amount of time, and I have not figured out what that is yet, mainly because I'm just busy with work and everything like that. But I've been giving it a lot of thought, and I feel like there's a lot of these little things that I just haven't been doing for you guys. And look, I really do. Like, I feel like, there's a lot of streamers and a lot of YouTube people who say they have a wonderful community, and they say, oh yeah, I know everyone in my community and all that kind of stuff, but I really do feel it's different. And maybe it's just because this is, our community and not their community, but I feel like there's something, like I really, really do feel like most of the people on this channel, most of the people I talk to regularly here are like close friends of mine. And maybe that's just because I'm socially awkward and I don't talk to people in real life too much, but I really do. I feel like I like know my community pretty well, and like I talk to them regularly, or at least listen to them talking. I'm kind of a lurker on Discord a lot of times, but yeah, I just appreciate this community. It's such a wonderful group of people, and I'm so happy to be a part of it, And I mean that genuinely. And I guess every YouTuber, every Twitch streamer, everyone says that. But I just feel it's different for us. I don't know. It's just different. Hey, Trash Talk, how are you? You don't know me, though. Maybe not. You're right. Maybe I don't know you guys. But I know a lot of the key players, right? So, yeah, I don't know. It's pretty cool. I like being a part of this group. It's just a good group of people. Friends will be friends. I mean, yeah. I don't know. It's nice. Okay. So what we're trying to figure out now is there are small scale exceptions to the Easter algorithm. Where are we? What am I doing with my life? Let me just go to computers again, because I don't, sometimes when, yeah. So the trick is, if you don't know what you're doing with your life, look at people who wrote algorithms from the 1800s. It seems to do the trick for me. Okay. So there are small scale exceptions that you have to do to Gauss's Easter algorithm down here. Basically, if D is equal to 29 and E is equal to 6, that's saying you are 29 days. Okay. What this means is that the Paschal full moon is 29 days from March 22nd. And then E is equal to 6, which basically means that your Paschal full moon happened on a Sunday, right? So if your full moon is 29 days away and it happened on a Sunday, then you have the potential to be off by a week, essentially, right? Because the Paschal full moon happened on a Sunday, so you have to subtract a week from that point, essentially. Because it would, for large numbers of D, apparently this can happen. The next error that we have to correct is if D is equal to 28 and E is equal to 6. And then this is a statement I don't understand. 11M plus 11 mod 30 is less than 19. Replace 25 of April with 18th of April. So I understand that if you have a large D, you can be off by a day. And if the moon, if you're 6 days away from the next Sunday, you might be off by a week or something. I can understand that. Okay, so here's the point. Right? If D is equal to 29, D is probably wrong. That's the thing. So D probably should have been on 28. Oh, I see what's happening. I understand now. Okay. So if D is equal to 29, it's probably off by a day, and it's meant to be the 28th, right? And if E is equal to 6, that means it happened on a Sunday, so that means your calculation is going to be wrong, right? You should have Sunday as your day, the following Sunday. Let me see if I can describe this properly. I'm just going to open up Zerdal and let's talk about it. Let me catch up on chat first, and then I'll explain it. This is my current understanding, and I think this is right. Wow, this looks complicated. It's an algorithm for the 1800s, right? Like, how complicated could it be? The answer is pretty complicated. At some point, you just have to say, I didn't ask to be here. I'm under no constraint to choose what I do with my life or to be useful. How did you get to this high school problem? It's just if, or switch case, nothing interesting. This stream was supposed to make me stupid. Okay, Radu, I am actually, if this stream isn't making you seem stupid, I am genuinely impressed by your intelligence. Like, genuinely. You are leagues smarter than I am. This problem has, boggled my mind. Fundamentally made me rethink how, I see, calendar systems. The whole thing is just, it's complicated. Right, I mean, okay, so for the record, this computation is not hard. I can easily just plug this into a calculator, right? This is straightforward. But understanding what each of these elements mean, and then imagining people doing this 200 years ago, oh, it's phenomenal. There's no way. There's no, I mean, I've been giving Gauss a lot of crap here, but it's such a complicated thing. Even A is equal to year mod 19. You have to understand what a Metonic cycle is. And that's something I didn't know before this. And then, B is year mod 4, this to deal with leap years. Here, let me just read through this set, right? Have you done video with the monkey? What monkey are we talking about? Sorry about that. Hey, Uncle Bill, how are you? So let me just read through this so you guys can understand why this is so complicated. So this particular method requires a calculation of A, B, C, K, Q, P, M, N, D, and E. And here's what all those variables mean. A is going to the year's position on the 19-year lunar phase cycle. That's also known as the Metonic Cycle. This tracks our location on that cycle, which is a 19-year cycle until the lunar phases are on the exact same day as the start of the cycle. So, for example, if Monday, January 1st, we had a full moon, then, 19 years later, the moon will be in that exact phase on Monday, January 1st, right? So it takes 19 years for the sun and moon to realign themselves. Then we have K, which is just a century index. And then we have another variable, which is P, which is going to be a shift of the Metonic cycle. Basically, what this does is it adds a day offset every 300 years, right? Now, the calculation here is the floor of 13 plus 8 times K divided by 25, right? 13 is just an offset. But what this basically says is that every 300 years, you're going to be a day off, right? So your lunar tracking will be a day off, right? So this calculation works by basically saying that 8 over 25, which is going to be this value down here, is roughly a third. So every 300 years, you add a day, and then you have 13 as an offset on top of that. In addition to that, every 400 years, there will be 97 leap days. K is already a century index, so every 400 years, K will be 4. Q is the next value here, which will then subtract 1 so that you get 97 leap days instead of 96 leap days. Right? So the idea here is that you have K and then Q. So basically you have K, which is your century index, right? And this will say that every 400 years, you'll have 100 leap days, right? Then you have P. Wait, 1 second. I need to think about this. Then you need Q to correct for K. So it's not 100, it's 96. I'm doing a very bad job of describing this. And so then after that, you need to do a correction to the starting point of the calculation for each century, mod 30 because the lunar calendar is about 30. So this is a combination of previous terms. So to figure out where you're at in the Metonic calendar, you then have to create M, which is, I'm doing an awful job of describing this. A very bad job. But you have to find M, which is basically where you are on the Metonic cycle, right? After this, you then have to find the next Sunday. So you found where you are in the Metonic cycle, which is a lunar cycle. Now you have to find a way to put that into the next Sunday. So it then gets complicated from there, even more complicated than it already was. It's just, there's a lot of just weird elements here that are very difficult to describe. So my point is, and I apologize that I didn't really go through this appropriately, and we went through it all yesterday. The point is, yeah, implementation-wise, this is incredibly straightforward. It's just a bunch of matrix multiplications, modulus functions. It's not hard to do. This is not a complicated algorithm, but it is a very complicated piece of mathematics. And this is something that I'm going to have a very difficult time. I am having a very difficult time even describing to you guys now. When I put it into the algorithm archive, I'm just hoping it makes sense. And that's kind of what we're here to do today. We're trying to find a good intuitive way to visualize this. And what I'm working on right now is just the historical corrections part, the last bit, so we can understand why it is what it is. So we're going to talk about that right now. Okay, and also I got another notification from work. I need to check that really quick. And it is, it's a lot of notifications as well. Let's see. I'll respond really quick, and I need to get to this in about an hour, so I'll let them know. Yeah, okay, I have to work on that in about an hour, so I'm ending stream early. Sorry, guys. I saw this documentary a couple of times about the Chinese calendar. When there were these European, some priests, and managed to beat the scientists in China in computation because they knew from Europe the logarithmic tables were created. So they could do big numbers using log formulas. Very interesting. There's a lot of interesting things about the history of mathematics. There's so many interesting things. What is this, determinist? It is a Twitter status, so I guess, nothing crazy there. Let's take a look. And I'll just put it here. And let's see what we got. Consider millions of years ago, our antecedents gave a massive sacrifice of their left hemisphere. We lost a tremendous amount of short-term memory and replaced it with Broca's, Wernicke, and the phonological loop. But why? So we can talk. Thus, chimpanzees can do this, and we can't. What are they doing? I'm interested. I don't know. Okay, I can look at that a bit later. I'm not sure what they're doing. Oh, those monkeys. Sorry, Twitter couldn't find it anywhere. It's okay. No, I appreciate that. I'm definitely going to look at this after stream. Let me just move this over here. I just can't look at it now. I don't. My policy is not to watch videos on stream because there's copyright issues with that. Okay. Although technically there are copyright issues for me looking at Wikipedia on stream as well. I just pretend that doesn't happen. Okay. Right, so let's talk about these corrections. So, the values that we care about are D and E, okay? I'll do lowercase d to keep our notation consistent. And actually, I'll change the color as well to green, just because, why not? D and E. So D is going to be the number of days until, and I'm just going to put Paschal full moon from March 22nd. Okay? And then E is going to be the number of days. Days from. Whoa, let me try this. For some reason, I just can't write today. From the Paschal full moon to Sunday. Okay, so we need to make corrections, right? So the first correction is if D is equal to 29. And I guess I'm just going to put an ampersand here. What does an ampersand look like? Is that an ampersand? Nice, I think that's right. No, wait. I've never actually... Am I the only one that's never actually drawn an ampersand? Like, it just doesn't come up in my daily life, ever. I've never had to draw it. And E is equal to 6. We need to make a correction. Now, the question is, why do we have to make that correction? And the answer comes from our Sketchy website over here that basically says the length of a moon month is not exactly 30 days, right? But 29.53. This means that for large values of D, but let me see, what is the calculation of D? D is going to be 6 times D plus mod 6 times D. Wait, what? What is D? I think his D is the same as our D, but I might be wrong. D is 18 times M, and RD is 19 times A plus M. Yep, so his D is the same as RD. So if D is equal to 29, E is equal to 6, there is a potential. Oh, I also love this statement. With Microsoft Internet Explorer, this algorithm will come alive. It's beautiful. It is absolutely beautiful. This website's wonderful. Okay. The length of a moon month is not exactly 30 days, but 29.53. This means for large values of D, we might find a partial full moon that is 1 day late, and if that happens to be on a Sunday, we will then end up with an Easter date that is an entire week overdue. Okay, so this means that if D is equal to 29 and E is equal to 6, that means the partial full moon happened 29 days after March 22nd, and then 6 days after that would be the next Sunday. So that means that the actual date is going to be April 26th. Okay? Now, in this case, D is going to be off by a day. So the partial full moon didn't happen on a Sunday. It actually happened on a Saturday, right? So because D is offset by a bit, this D should have been 28, right? And because it should have been 28, E should have been equal to 1, meaning that instead of being April 26th, the actual date should have been April 19th. Okay? And now there's another correction that we do. If E is equal to 6, and the other correction is if D is equal, I'll just draw a line over here. The other correction is if D is equal to 28, and E is equal to 6, then what and we're on the second half of the Metonic cycle, which means there's more error accrued there, then we're in the same situation where our D is offset. Our D isn't correct anymore. So we have to then again subtract 7 from there. So we then have April 18th as our date, right? So these are basically corrections. Now, one thing that there is a historical element about this that I'm not really entirely sure about, because April 19th is overrepresented. If you look at the date, the whole 5 million year cycle for all the dates of Easter, you do clearly see a slight overrepresentation. Oh, it's a slight overrepresentation of April 19th, right here. That's what. Oh, just for Pete's sake, let me just. Okay, you see. Oh, just, come on, man. You see a slight overrepresentation of April 19th here, and that's because of this whole like subtracting a week thing. But now, what I'm trying to figure out is that I don't know if this is mathematical or historical. Wikipedia says it's mathematical, but our Sketchy website says it's historical. And my gut tells me to believe the Sketchy website over Wikipedia. Okay, let me go ahead and catch up on chat. Sorry for Twitter couldn't find YouTube. That's pretty neat. Or not related to the current topic. I do it a lot. It's okay. You don't have to relate to the current topic to be in chat. It's fine. There's no reason to worry about it. Let's see. I made a dedicated effort in high school one day to learn how to draw an ampersand. Early stream? Yeah, stream started a bit early. Sorry about that. I just got my time zones mixed up. We should hire chimpanzees for jobs that require a great deal of short-term memory. Oh, yeah, probably. We have Twitch clips for that Negatron. Oh, understanding the algorithm is important to load such short-term data. 26 forced to 19, I think. Yeah, Wikipedia does say it's historical, right? But if it's historical, right? So that would mean that if it's for historical reasons, that means we hardly ever actually calculate. April 26th as a real date of Easter. Because if April 26th was just as common as every other day, then this would be double. April 19th would double. So we have a 1, 2, 3, 4, 5, 6, 7 days ramping up, and 1, 2, 3, 4, 5, 6. Okay. So we have 7 days ramping up, but only 6 days ramping down. So my guess would be that, like, basically this 0.5% here, this little bit here, was added on top of here because we're missing a day over here. Does that make sense? Like, it should be symmetric, but it's not. So I think that's kind of one thing. And we have a slight overrepresentation of 18 because of the other situation that we had to deal with. Whereas if we're on the other half, the Metonic Cycle, this is so weird. Why is there such a dip from here to here? What is that dip doing? So see, it kind of goes up in even steps along here, but it doesn't along this way. There's a big drop here. And that's because, there's a big drop because if you're on the second half of the Metonic Cycle, it's going to add to 18. But why, if it adds to 18 here, why is that only so high and not... Oh, maybe that's right. So maybe this is supposed to be at this level. And okay, yeah, I'd believe that. I'd buy that. It's probably some combination of both. Could be. It's going down after 19 anyway. Right. Yeah, 19 is going to be, like, again, I think it should be symmetric, right? Because if these are truly random numbers, it should be symmetric, but it's not. That's the thing that bugs me. Does the 19th of April have anything to do with 19 years in the cycle? No, so I don't think so. So the 19 years... Okay, maybe there's a historical reason for that. Like, maybe people were just like, I like 19 because of the 19, years in the Metonic Cycle or something. But I don't think that's true. I think it's unrelated. Let me get some water. Man, this is kind of insane. Like, okay, going back to what Radu said earlier, right? This isn't a complicated algorithm. It's just a complicated heap of mathematics that just does not make intuitive sense, at least to me. I mean, maybe to other people, like they're just watching this and they're like, oh, this is super straightforward. Everyone understands this, but that's not me. Nope. I have absolutely no idea what's going on. So we'll just keep going. Let me go back. And let me see if they give a bit more justification to this historical thing down here on Wikipedia. Also, let me see, are there any dates coming up? No, we don't see this anytime in the near future. We won't see this April 19th thing happen. What I was hoping to do, like what would be absolutely beautiful, is if there was one Easter coming up that was April 19th, so that we could say on that year, I don't know. I was hoping to be able to say that, this year is the median Easter. It's the most likely Easter. Okay, so let's pop down here and let's see what we got. I'm just going to reread what Wikipedia says, and then I'm going to reread what our Sketchy website says, and we're going to see if we can get a good grasp on what's happening here. So let me make this a bit bigger so you guys can read it, and we're just going to... Oh, that's not bigger. That's the opposite of bigger. Some would even call that smaller. Okay, I'll make it 150. So this is 1.5 times what I can see. Okay. Well, I mean, it's 1.5 times what seemed reasonable on my computer. And also, let's do the same on the Sketchy website, which is also 150. Oh, I love this Sketchy website. It's such a beautiful website. Man. Okay. It shouldn't make intuitive sense because calendars don't make sense. I guess that's a fair point. Okay, I found these Jesuit priests from 16th century, Johann Adam Shaw von Bell and Ferdinand Verbiest. That Verbiest managed to get the head of the math board and astronomy in China. Oh, super cool. So these are the guys that you were talking about earlier, that understood logarithms and stuff like that, and therefore dominated Chinese mathematics. It's really cool. Okay. Just refocus. Let's try to figure this out. Oh man, I love this stream so much. Okay, so the expression d plus e, I'm reading from here, yields offsets in the range 0 to 35, pointing to possible Easter Sundays on March 22nd to April 26th. For reasons of historical compatibility, all offsets of 35 and some of 34 are subtracted by 7, jumping one Sunday back to the day before the full moon, in effect using a negative e, or negative e of -1. This means that 26th of April is never Easter Sunday, and 19th of April is overrepresented. These latter corrections are for historical reasons only, have nothing to do with the mathematical algorithm. However, our Sketchy website says the opposite. Our Sketchy website says, finally, there's one caveat left. The length of a moon month is not exactly 30 days, but 29.53. This means that for large values of D, we might find a Paschal full moon that is 1 day late. And if that happens to be on a Sunday, we'll end up with an Easter date that is an entire week overdue. This means that for large values of D, we might find a Paschal full moon that is 1 day late, and if that happens to be a Sunday, then we'll end up with an Easter that's an entire week overdue. Therefore, the final correction, if f is equal to 57 or f equals 56, just different notation, but the same thing we were saying before, then we must subtract 7. The result is April 26th, f equals 57, then subtract by a week. And if the result is April 25th, and the day after the Paschal full moon is a Monday, and the year is in the second half of the Metonic Cycle, then we subtract 1 week. The moon month is not exactly 30 days. So how is this related to the fact that the moon month is not exactly 30 days, but is instead 29.53? How does that statement justify this behavior? Also, what's happening up here? What is this? Can I just pull this up really quick? Every time I go to this website, I'm just impressed by this guy. So here we have a GIF of Happy Easter, right? But let me just go back really quick. He's got another Happy Easter GIF. Let's just do view image. Here's a Happy Easter GIF. And then here's a Happy Easter GIF. And then here's another one. He's got an endless number of Happy Easter GIFs. Like, this guy's whole website is just related. I don't understand any of this. It doesn't relate. So Cropep is saying that this is purely for historical reasons, and that this Sketchy website with a number of Easter gifts. I mean, look, this guy's whole career is based on just calculating the date of Easter in 2020. I mean, so you're saying that it's only for historical reasons. Okay, so what I'm trying to explain then, if it's only for historical reasons, I just deleted the wrong. Okay, if it's only for historical reasons, what I don't understand, and what this paragraph doesn't explain, is this guy. It doesn't explain if D is equal to 28 and E is equal to 6. It doesn't explain that statement. That's one I can't figure out. This only makes sense if we're on the second half of the Metonic Cycle. And we know this says we're in the first half of the Metonic Cycle, doesn't it? Unless I misunderstood. You remind me of the guy from the TV show Arrow. I don't know what Arrow is. What is this? I mean, if someone says I look like some guy from, like, a show, I guess that's always a good thing. I think explanation for 25 to 18 might also be true for 26. Wait, let me think. Right, so that's the thing. If 26 is only for historical reasons, then that explanation doesn't make any sense. Because why? But the Sketchy website gave an explanation that could make sense if and only if I can figure out how to relate that 30-day offset to this. You know, if I can figure that statement out. But I think you guys are right. I think if it's done for historical reasons and not mathematical reasons, that explains why 29 and why April 19th and April 18th are overrepresented. So the full moon is at 11 p.m. March 20th. Wait, I'm listening, Cropep. Let me go ahead and get some water as well while you type this out. So if full moon is at 11 p.m. 20th of March, I mean, the next full moon should be 30 days from that, roughly, right? Or 29.5 days from that. So then that would mean that it's going to be at noon, I guess, of April 19th, right? I think that's right. 18th of April, right? Not 18th of March. 11 a.m. And I think it is 29. Wait, so 30. Let me think about this really quick. So if it's 11 p.m. on the 20th of March, and 30 days from that is going to be 11 p.m. on the 19th of April. So then if it's 11 p.m. on the 19th of April, then it should still be the 19th of April, right? So it should be Sunday, then it would be the 26th. And if it's the 19th of April, and let's say that is on a Sunday, then you're right, that would be April 26th. But what does the second half of the Metonic Cycle mean? Does that mean we accrue more error? Why does it matter that we're on the second half of the Metonic Cycle? That's my question, right? That's what I don't fully understand. And also, like, this thing that they put on Wikipedia actually says something else. Like, this thing that they say on Wikipedia, if 11n plus 11 mod 30 is less than 19, doesn't that mean we're on the first half of the Metonic Cycle? Am I just wrong? Maybe I'm just an idiot. Calendars make so little sense that there's on December the 13th month in Java's calendar library, just in case. Yeah, calendars, man. They're a pain. Let me get some water. That's actually a beautiful statement about how humans cannot adapt to the systems that we've created. Okay. So let me see what our Sketchy website says. I'm sorry, I keep going back to the Sketchy website because it's not bad. That's not Easter, that's bowling. Oh, then it's Easter. Dang it. Okay. If the result is April 25th, and the day after the partial full moon is a Monday, and the years in the second half of the Metonic Cycle, then subtract 1. So here's his note. A ranges from 0 to 18, so the threshold of A is greater than 10. Means, it's just explaining why A needs to be greater than 10. So why does it matter if we're on the second half of the Metonic Cycle? That's what I don't understand. Let's take a look at this. So our calculation of A, mod 19, is going to be, that's going to tell us where we are on the Metonic Cycle. Now, again, why do we have to be in the second half? Like, that seems like an arbitrary... Okay, so for those of you who don't know, the Metonic Cycle is a 19-year cycle that basically tracks the difference between the lunar phases and the solar phases, right? So the sun is, we're orbiting the sun 365 days a year, and the moon orbits us. And the idea is that, we have, basically, if you have a full moon on the 30th of March, then, or we'll say 30th of April, the next full moon is going to be about 30 days from that. But yes, I guess what we can do is we can track the divergence. Between the lunar and solar cycle in a way, and then explain that at some point it just returns to where it was before. And I need to figure out why. Right, so Cocaine, what we're doing here is again, exactly what Fulster says, we're trying to understand when Easter is. Now, the truth is, we know when Easter is. We have an algorithm that does specifically explain to us when Easter is. We've implemented it, it works, it's fine. But there are specific corrections to this, and like Amara said, down here. And these corrections are if we're 29 days away from March 22nd, right? And on top of that, the next Sunday, I need to re-describe this. Okay, the way you calculate Easter is by first finding the partial full moon, and then calculating the date from the partial full moon to the next Sunday. D is the number of days since March 22nd, which again is the first March in spring, or the first day of spring, to the next full moon. So that's the idea. So D is from March 22nd to the next full moon, right? And the partial full moon is the first full moon in spring. Now, so if D is equal to 29 and E is equal to 6, right? And E is equal to 6. That means that our partial full moon happened literally as far away as possible from March 22nd. And not only did it happen as far away as possible, but also it happened on a Sunday, so the next Sunday isn't until the following week, right? And in this case, when our partial full moon happened super far away, as far away as it could, from March 22nd, and our next Sunday is a full week away, we then apply a correction where we just subtract a week. So we say, okay, actually, what we're going to do is we're going to have our Easter celebration a week early, right? And this guy says if D is equal to 28 and E is equal to 6. So this means that the full moon happens on almost one day away from being as far away as possible. But it also happens on a Sunday. Then we're just going to replace that. Again, we're going to subtract 7, so we're going to do it the week before. But the issue here I have with that is that we only do this replacement if and only if we're on either the first half or the second half of the Metonic Cycle. And no one's really explaining to me why that matters. So I'm doing a very bad job of describing this, but it's a bunch of weird mathematics that... So this guy is explaining... So this guy just says for large values of D, which D can only range from 0 to 30. Or not even from 0 to 30. It can only range from... No, I think it's from 0 to 29. We might find a partial full moon that's one day late. And if that happens to be a Sunday, then we end up with an Easter date that is an entire week overdue. Therefore, the final correction, if f equals 57... But why does it matter if we're greater than 10? Okay, let's think about this. Historical corrections, 26th April, 19th April especially. Right. But what I'm arguing is I'm not... Okay, we can just say in the algorithm archive that these are historical corrections, right? We can say that. That's fine. I don't mind saying that both of these guys are just historical corrections that we have to place on the system. But, people are indicating, or there are indications from sources online, sources that we have so far trusted, that are stating that potentially these aren't just historical corrections. These are actually mathematically necessary corrections. And if they're mathematically necessary corrections, then we need to understand them. But we can waive them away as just historical corrections. I mentioned the animation is just going to be a bunch of Sawtooth waves added together. That's exactly what the animation would look like if we did an animation of the divergence between the Metonic Cycle and the divergence between lunar months and solar years. So what I might have to begrudgingly say in the algorithm archive is I might have to say that these two modifications are for historical accuracy only. Even though there might be some math there that I'm missing. I mean, I'll state that. Obviously, I'll say there are some indications that there's a mathematical reason for this. Let me see. Let's just look up. I'm just going to Google some Easter algorithms. Gauss's Easter algorithm. Corrections. Let's see if we can find another source. Maybe there is. Probably there is, right? And maybe it describes it a bit better, and I'm just being an idiot. Yeah, like these guys. These guys are quite good. I don't know how I missed them before. Never mind. These guys aren't good. These guys aren't... I don't understand what they're doing at all. I need text. Okay, let's maybe try another source. Calculate the date of Easter. Carl Friedrich Gauss, I don't care. Let's look at this again. Will they ever happen in the future? Statistically, I'm confused why only 25 has to be fixed. Well, 25 and 26 both need to be fixed. So April 26 has to be fixed. And April 25 has to be fixed. But not... Right, my question isn't why April 26 and April 25 need to be corrected. My question is why is April 25 only corrected half the time? That's what I don't understand. What happens if these corrections are removed? Is there a way to simulate dates of the moon phases and check the accuracy of the algorithm under certain conditions? The answer is if these corrections are removed, what you will see is this is a simulation of all the dates of Easter for the entire 5,700,000 year cycle. Okay, So this would then become symmetric. So we wouldn't see this peak anymore. Instead, all of the extra numbers from here would go back over here to where the 26th would be. And then this little peak right here, there's a little peak on the 18th, would then be moved over here to the 25th. So that's what we would see. We would see it kind of ramp up for 7 days, be roughly equivalent, and then ramp down, right? There's some variation in here, but for the most part, that's what we would see. What happens if those corrections are removed? Sorry, I just found the name Draconic Month as a measure of time. What does that mean, Draconic Month? Oh boy, I don't know why. Look, I know I might be sounding frustrated, but I'm actually genuinely enjoying this. Draconic Month, and I hope you guys are too. Like, yeah, we're struggling to learn things. We're trying to figure things out. Is it Draconic Month? It's also known as a nodal month or nautical month. The name Draconic refers to a mythical dragon said to live under the lunar nodes and eat the sun or moon during the eclipse. What? A solar or lunar eclipse is possible only when the moon is at or near the 2 points where the orbit crosses the ecliptic plane. Satellite is at or near either of its orbital nodes. Right, Cropip, I'm also with you. Let's see. From what I can find, it might have something to do with the fact that Easter's date is 5 days after April's full moon. It might have something to do with Easter's date. It's 5 days after April's full moon. So that maybe there are two, and maybe that happens, we need to correct for that. Right, so in the case that D is equal to 30, or 29, because 29 is as high as we can get, that means a full moon happened, essentially, on Sunday, March 22nd. And then another full moon happened at the very end of the cycle, right? So there are two full moons that you could have counted as a past show full moon, so there could be something like that could have happened. But I don't know why they just correct it by a week at the end there. That seems kind of weird. Okay. Let me just see if there's something else. Lunar month, Java. What am I looking for? What am I doing with my Gauss' Easter algorithm? Why do math? Do these guys mention the correction? They don't even mention the correction, honestly. Yeah, they don't seem to mention it. Yeah, because it's not relevant for 2001. Let's see. Here's computers and algorithms to compute Easter. I love this so much. Knuth, known for his work in computer science and algorithm, implemented an algorithm to compute Easter. I mean, if Knuth did it, we have to do it as well. Let's see. No, this doesn't really describe... I mean, unless you can click on this. No, I don't think it does. It doesn't describe the method in rigorous detail. It just says that it exists, you know? Easter algorithms from GM Arts, probably. Well, maybe there's something here. No, there's not. Nope, this isn't... Okay. Right, that's not Gauss's method. I can tell you that. That's not... So without the mod, it'd be more like more than 59. Let me see. So there are two overflows. Okay, so let me see what CropUp is saying here. When is my real birthday? Oh, you must have been here yesterday. Gauss actually didn't know his real birthday. So the story is that Gauss didn't know his actual birthday. And he used this method not only to calculate Easter, but also to calculate his birthday. Because he only knew it on like the lunar calendar, not the Gregorian calendar. Oh, that's another algorithm, actually? Yeah, I think so. So without the mod, it might be more like 59. So it might be fixable by doing 59 mod 30. So lunar month is 29.5. So without the mod, it might be more like 59. So okay, what you're saying is that... I'll let you finish the statement, and then I'll come back to it. Because I'm still trying to parse it together myself, or piece it together. Anyway, welcome to Simuleos, the channel where we just look at old math and hope that someday we can make sense of it. So 2 months is 59, and not 60. Okay, right. So mod 30 is one off. Wait. I think yep, that's it. That has to be it. So lunar month is going to be 59 days, not 60. Okay. So if d is equal to 29, if d is equal to 29, if d is equal to 29, so this guy's saying is if f is equal to 57, or f is equal to 56, which again is similar to what we said before, is very close to 59. Then, so what is their f? Their f is 22 plus d plus e. So it's accounting for a rounding error introduced earlier. So I think it is, but I still need to process it. It's not clicking in my mind yet exactly what this is doing. So f is going to be 22 plus d plus e. So f is going to be, so if our d is 29, so that means it's going to be 22 plus 29 plus e. Now the question is, why are we tracking 2 lunar months? Okay, so let's just think about this. So if f, and I don't think there's a mod 30 in there. So d is going to be 29 and e is going to be 6. So in that case, we're going to add 35. We're going to add 35 to 22, which gives us 57. You can't get up to 59. There's no way you can get up to 59. Because 22 is the start, the earliest count, 29. So d plus e is going to be 35 at most. 22 plus 35 gives you 57. 57 is as large as that count goes. But maybe, okay, maybe. There are some mod 30s, but the mod 30 isn't on any of the. Okay, there is a mod 30 in the D. Should we just output? So there is a mod 30 in the D. It's going to be 19 plus A plus M. And there is a mod 30 in the M as well. So yeah, maybe D itself is a mod 30, right, is what you're saying. So if it's 29, what is A? So A is going to be, A is our location on the Metonic calendar. Okay. So A is our location on the Metonic calendar up here, right? So it's going to be 19 times A plus M, and M is going to be a correction for the starting point. So what we're looking for here is we're looking for 19 times A. And the reason it's 19 is, again, to correct for an offset to lunar months. And 19 has nothing to do here with the Metonic calendar. It just happens to be 19. So it says the moon year is 12 lunar months, which is 354 days, which is going to be 365 minus 11, and mod of minus 11, 30 is equal to 19. So this is going to be a half year offset. It's handled by leap days later. Okay. Regardless, this is related to our offset on the Metonic calendar. So what this would be saying, if the Metonic calendar is a sum. Okay, I think I'm understanding it now. Okay, so if the Metonic calendar is just going to be, a list of months, right? Let me see if I can. I think I got it. So journal, new page 4. I don't know, but let's pretend I do. So we've got a list of years down here, which I'm going to do in green, and a year of lunar months in here. So this will be tracking the whole 19 years. So this is going to be year 0 down here to year 19 in here. Okay? My brain is officially out. I think I'm going. See, Ambrose, thank you so much for coming in. Have a wonderful evening, and hopefully I'll see you around tomorrow when we do some more visual things. So this means that we have 19 dashes in here. Something like this, okay? In here, we have our lunar months, right? And this is going to go, again, from 0 to 19, but in actuality, it's going from 0 to 19 times 30 or whatever. No, wait. It's going to be going from 0 to however many months, lunar months is going to be in 19 years. So that's going to be n, however many that is. Okay, so my argument is somewhere halfway between this thing, we're off by a day. So at about this point in time, we're now off by a day. Because of that offset in the month, right? So what I'm going to say is if we're... This is my guess. Somewhere halfway in there, we're off by a day. At almost precisely halfway. So let me just think about this. So what is n in this case? So n is going to be... what is 19 years in days? So let's just do this really quick. I'm going to open up Julia. So 19 times 365. Okay, it's going to be that. And what we're arguing is that there are 29.5 days in every lunar month. So let's divide that by 29.5. So we'll do 19 times 365 divided by 29.5. And if we do the same thing divided by 30, we get a 4-day offset, essentially, between the two of them. Which would mean... you probably do need to take into account leap years, right? We have 40 off. I'm confused as crap. A year is 364 days every... Okay, right. So I'm an idiot. Wait, what? No, it's 366 days every fourth year. I'm just doing some rubbish math then. Yeah, this isn't as easy to compute than I thought. 365.25 minus 1 over 128. Let's just put that in there. So it's... Oh, actually, why don't we just put 365.25, okay, times 19. So that's our entire Metonic cycle. And then we're going to divide this. Oh, but we know exactly what that is. Let's just go to the Metonic cycle in here. And, it tells us. There's the word astonishingly. Close to. Dang it. Remarkably close. So, it's this many days. This is what we have. That's the number of days. Oh, I'm so confused. Let me just catch up on chat and then I'll get back to this. That should be a massive rounding error. Yeah, I guess so. So that mod can be applied on 18 times 19. You don't need to account for leap years. The amount of days in a year isn't an integer, it's a float. I agree. And not only 2020 is a leap year, but also first year of 12 Chinese calendar. Okay. So I was just saying, yeah, you're right. I should just read the sentence. The sentence says that in older times, 19 calendar years were equated to 235 lunar months, which is remarkably close since 235 lunar months are approximately 6,939 days, and 19 years are an average 6,939 days. Okay. So, right. I don't understand what this offset is now. I'm lost. I'm confused. I'm 90% sure most sources are going to claim that this particular change, these statements here, are specifically for historical context. Earth rotation is slowing means our days are getting longer, which means our years will be longer. No, I mean, obviously it's not slowing enough for us to notice, but it's still correct. I mean, technically, I think you're correct, but like, we're talking about what they knew in 1800. Like, we're not even at that stage yet. Okay, so let me think then. So we know that this is basically the number of days that are in every Metonic cycle. So every 19 years is this many days. It isn't even a float unless it's equal to 1. Yeah, right. I agree with you, Negatron. Okay. So What am I trying to say? I'm trying to say that for large values of d, again, d is equal to 29, we're going to have to for large values of d, if and only if the full moon happens on a Sunday, we need to subtract a week. That's what we need to do. The reason we have to do that is for A, historical reasons. Yeah, we need to invent real value arithmetic chips to truly calculate Easter. Yeah, there we go. That's the first thing we calculate. We're going to get the most precise chips ever invented for real value arithmetic, and we're then going to calculate Easter. That's the number one thing we're going to calculate, because I'm sure architectures that can do that are going to be great at this type of computation. Right. So again, just to be clear, just to make sure everyone understands, my issue isn't with this statement. If d is equal to 29, e is equal to 6, that's saying that if our full moon happens on a Sunday as far away from the 22nd of March as possible, we have to subtract a week from that calculation. I don't actually have an issue with that statement. The statement I have an issue with is this one. If d is equal to 28, e is equal to 6, and 11m plus 11 mod 30 is less than 19, we replace the 25th of April with 18th of April. That's the one I have the issue with. For two reasons. One, I'm not actually convinced this is doing what they think it's doing. They're saying that if you're on the second half of the Metonic Cycle, you're going to have to subtract 7 again. But I'm not sure why the Metonic Cycle even comes into play here. That's my question. When will we see your algorithm site? Is it going to be like Simulator's Easter algorithm? I already have a branch available you can take a look at. With real value arithmetic chips, we'll need uncountable programming languages. Otherwise, it won't really be an improvement at all. Yeah, that's true, I suppose. Yeah, why does it matter where we're on in the Metonic Cycle? If we're on the second half of the cycle, which means we're... So, like, I can explain why this looks the way it does. I can explain this peak. I can explain this little peak here. I can explain that. But based on us putting for us doing the calculation, right? I can explain that. What I can't explain is why we do these corrections to begin with. And that's where I'm left. That's where I'm at. That's why I would be... Gauss wins again. I don't understand why we're doing this. So maybe we leave it there. Maybe that's what we do. Maybe we just say that these are done for historical reasons. I can't explain why mod 30 is allowed. Yeah, I also can't. What I can't explain is why church was so stubborn not to put a fixed timestamp. It is kind of a fixed lunar timestamp is the thing. It's just not a fixed Gregorian timestamp. That's the issue, right? Like, I mean, it just happens during the Paschal full moon. Everyone knows when that is. It's not hard to calculate. On the lunar calendar, it's easy. But on a solar calendar, it's not. And that's the issue, right? Because we have both the sun and the moon that we have to deal with. It's just complicated. You know, if we only had one celestial body, it'd be fine. Ideology sniffing raccoon. Thanks for following. I really appreciate it. So yeah, maybe that's it. Maybe that's what we do for today. I want to go back in time and ask him. Okay, here's the thing. If you would have gone back in time and asked him, and this is the thing, people did ask him during the time. He said that he didn't even explain the method. All he said was, this is higher level math. That's what he said. Let's get rid of the moon so we can figure out when Easter really is. Yeah. What was it? There was one show where they got rid of the moon. Oh, it must have been Dragon Ball Z. That was it. They removed the moon in Dragon Ball Z or something like that. Right, so let's see who's online, who we want to raid. Adam13531 is live, but I think we raided him yesterday. Lana Lux, Dr. WD40. Oh, he's talking about COVID-19. Maybe that's important for a lot of people here. Raimu, Calocreation. Let's see, Tim. It's up to you guys. Does the first paragraph above the table explain it? No, the first paragraph above the table, where are we? Over here is simply saying corrections to the algorithm. So this is right here. It is in 1800, the mathematician Carl Friedrich Gauss presented this algorithm for calculating the date of Easter in the Julian or Gregorian calendar. He corrected the expression for calculating the variable p in 1816. In 1800, he incorrectly stated p equals the floor of k over 3, whatever. So this is just corrections that he did. No COVID-19, I'm hearing that all day. Fair enough. Easter isn't when Jesus died. You're correct. It's when he was resurrected, but this isn't the point of today's stream. I'm not getting religious here. I'm just calculating a date. So let's do, how about we just do Lana Lux? I feel like we haven't done her in a done her stream in a while. So let's do that one, I think. I think that's a good one to go with. Or Loading Artist. I think that's fine. 1807? So you're saying 1807? What are you saying for 1807? In 1807, you replace the condition 11n plus 11 mod 30 over... Yeah, but a greater than 10 is the same as saying we're on the second half of the Metonic cycle. That's the same as saying we're on the second half of the Metonic cycle. So I can modify this, and I can say... yeah, let's just say a greater than 10. Ah, crap. Crap, I didn't write it. Let me fix that. Crap. Okay, so we're gonna move down here, and we'll say if, and let's look at these statements. D is equal to 29, E equal to 6. And E equals 6. Or, it should be D is equal to 28. And E is equal to 6. But here's the thing, it's A, yeah, which is correct. Where's my ampersand? For Pete's sake, A is greater than 10. And we'll say E is equal to -1. I'm going to write that so I don't forget it. Weird that Wikipedia uses the weird one. Right, I think it's because it was showing the original 1800 algorithm. From 1 to 19, A goes from 0 to 18, correct. So at 10, you're actually right in the middle. Correct. Well, yeah, like it's from 1 to 19. Well, right, but actually if it's greater than 10, is it greater than or greater than or equal to 10? It is greater than 10. So that means you're not going to, okay, regardless, you're at about half, right? So at about halfway along the Metonic cycle, at about halfway through the Metonic cycle, you then need to add 1. Does this help you in any way, Cropet? Because if you understand this, let's just wait and see. Because I'm lost. I don't understand. I don't understand the justification for doing this at all, unless it's historical. So I'm just going to go ahead and say these are historical corrections. If the date of Easter for April 26th and 25th, if we are on the second half of the Metonic cycle. That's what I'm going to say. You're right. The last 8 years. I don't know. What do you think? I think what I'll do is I'm going to state that there is some... I'm just going to leave this as an exercise for whoever's reading the algorithm archive. Like, I'm going to say, look, there's some ambiguity here that I couldn't understand related to date or the length of each month, lunar month, 29, 5 days, which could mean that this is actually a mathematical offset. I'm just going to put that in the algorithm archive when I write it up, but I just don't understand. So the problem is, I feel like these have to be historical, like, these have to be historical reasons, because otherwise this curve would be flat, right? I don't know. No. The curve wouldn't be flat. April 26th is a perfectly valid date to have Easter on. But they just decided they didn't want to have Easter on that day, essentially. Like, why isn't April 26th okay? Because all we're saying is that the full moon happened on a Sunday, and that we're just celebrating it the following Sunday. Do other algorithms? The algorithm in the Sketchy website had it, a greater than 10 here, and I think a few other implementations I've seen have it as well. So I think what I'm gonna say is that these are perfectly valid. Maybe it has something to do with the position of the equinox. Could be, right, because if we're on the second half of the Metonic cycle, the position of the equinox would change, so that it's not technically on March 21st. It's technically... Actually, I might buy that logic, because if we're in a different part of the Metonic cycle, the equinox date will technically not be March 21st, so that day is wrong. And therefore, if we're on the second half of the Metonic cycle, could be... When is... dates... versus Metonic calendar. Something like this. I don't know. Let's just do equinox dates. Oh, I don't know. This isn't going to give me what I'm looking for. Because it could be if we're on the second half of the cycle. Let me see if we can find equinox dates. Does not mention equinox. Let's go back. Calendar time date by stars, sun, and moon. Equinox. I don't know, but the equinox date does shift. So there is the potential that on the second half of the Metonic cycle could be that the date of spring, the equinox is on like the 18th of March or the 19th of March or something like this, which would mean that we're off. Yeah, that could be true. That could be it. But I think maybe that's where we're at. I think that's where we'll stop today. Can you email the Vatican and ask? I could. I don't know if they'll give me any answer. Long ago, the Christian Church decided to simplify the process of calculating Easter dates by always observing the spring equinox as March 21st, despite the fact that the equinox date changes over time is actually getting earlier. But it's getting earlier. Date of the equinox. Let's see, what was the equinox this year? We'll do spring equinox. We say it is going to be on 2020. It's going to be March 20th. Right. But I'm looking for... This is a long cycle. It's on the 20th this entire time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know. In March, the equinox is on 20? Right. I don't know. I'm kind of lost myself. I mean, maybe it is an equinox, but I'm going to put that in, and I'm going to say it could be an equinox correction. Could be an equinox correction, because I think you might be right. Where the second half. Okay. I think that's where I'm going to stop today. Let's do git add Gauss Easter .jl git commit -m And we're going to do adding corrections based on, oh my gosh, based on a Metonic Cycle, something like this. And then we're going to git push origin master. Okay. I'm not the best at math, but I sure do love listening, learning, and thinking along. Well, hey, I'm so glad you're here. Can't be the Equinox correction. Okay. Well, I think that's where we're going to stop for the day. Didn't I just do this? Okay, whatever. It's now pushed. Feel free to take a look at it on Simuleos Master. And we're going to go ahead and raid we're going to go ahead and raid Lana Lux at the end of this. Because then the partial full moon would be 1 lunar month earlier. That's more than 7 days. Right. I think you're right. Okay, I think we're going to stop here for the day. If you guys want to keep having this discussion and talk a bit more about it, please feel free to go to Discord. I'm also very interested to hear if you guys have any ways in order to visualize this. We need to have a good way to show, basically the Metonic Cycle and the Gregorian calendar. I need to find a good way to visualize all this so it becomes easier for people to understand. But maybe even just a good description in text is enough. I just have to... I need to put all the pieces together, and I don't know exactly how to do that right now. So if you guys have ideas, feel free to mention it on Discord. We can continue the conversation there. Otherwise, I'll be back tomorrow, same time, same place, doing what I can to make this as intuitive as possible for everyone. And hopefully I'll get a video out this weekend. That's what I'm shooting for. So we'll see how that goes. Thanks again, guys, so much for coming in. I'm going to go ahead and start the raid on Lana Lux. And let's go. Okay. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens of your time. And I'll see you guys around next time for the next episode of Simuleos, where we do exactly what I just said, just visualizations for the Easter algorithm. And I'm happy that you guys were here. Bye, guys.